Okay, today we're going to be looking at Learning Target 8C. This is part 2. We are continuing to look at the intercepts of linear equations. All right, so just to review what we looked at in the last video, intercepts, again, are where the line, or the graph of the line for the equation, crosses either the x-axis or the y-axis. So this point right here is on the x-axis, so that would be our x-intercept. So again, we are looking at where the line is crossing the x-axis, and the y-coordinate here will always be 0. This point, this would be our y-intercept because that's where the line is crossing our y-axis. And for y-intercepts, our x-coordinate will always be 0. Okay, so what we're going to focus on here in this video is learning to use the intercepts to graph an equation. So if I said graph 4x plus 8y is equal to 24, at this point we know how to fill out an input-output table, choose the values of x, use the equation to get the values of y, and then plot the points. So instead of making a table, what we can do is we can look for two specific points, the intercepts, and then use those 2 points to graph the line. Okay, so first step, if I want to find the x-intercept, remember this is where we're plugging in 0 for y. So when I plug into this equation here and replace y with 0, this term disappears, right? Because 8 times 0 is 0. So I now have 4x is equal to 24. Divide both sides by 4, and x will be equal to 6. So the point is 6, 0. Okay, then I'm going to find my second intercept, my y-intercept. To do that, I'm going to plug in 0 for x. 4 times 0 is 0, so that term goes away, and I've got 8y is equal to 24. Divide both sides by 8, and y is going to be equal to 3. So this point is 0, 3, because we always list x first, then y. Okay, so now that I have these 2 points, I'm going to plot them on the graph. So for the x-intercept, when I start at the origin and I go over to 6, 0, that first point is right here. For the y-intercept on the y-axis, I go left or right 0 and then up to 3 so that I'm on my y-axis. There's that point. And now that I have those 2 intercepts, I can draw the line between them. And that's it. That's how we use intercepts to graph an equation. Okay, so let's try another example here. All right, if I were to give you 6x plus 7y is equal to 42, how would we graph that? All right, so x-intercept. Again, we're going to be plugging in 0 for y. 7 times 0 is 0, so I'm left with 6x is equal to 42. Divide both sides by 6, and I have x is equal to 7. So that point is 7, 0, because again, we always list x, y. All right, for the y-intercept, same equation. We're going to plug in 0 for x. And so 6 times 0 is 0. That disappears, and I'm left with 7y is equal to 42. I'll divide both sides by 7, and y will be equal to 6. So this point is 0, 6. All right, so then I can graph my 2 points. 7, 0, that's going to be all the way out here. It's a little bit off my graph, but we can kind of imagine where that next line or tick mark would be. And then 0, 6 is all the way up here. And draw the line between the two. All right, let's try one more example here, which is going to be a word problem. All right, you're helping to plan an awards banquet for your school, and you need to rent tables to seat 180 people. Tables come in 2 sizes. Small tables can seat 4 people. Large tables can seat 6 people. So first thing we want to do here is come up with an equation to model how many of each table we need. So when we think about that, we kind of have like 2 main things, right? We have the number of people who are going to be seated at small tables, plus we have the number of people who will be seated at large tables, and that has to add up to a total of 180. And so if we let x stand for the number of small tables we have, and y stand for the number of large tables that we need, then we can say, well, if each small table can seat 4 people, 4 times x, so 4 people per table times x, the number of tables I have, plus 6 times y, so 6 people per large table times y, the number of large tables I have, that has to add up to a total of 180 people seated, right? Okay, so here's our equation to represent the situation, and now we want to graph it, and we want to use the intercepts to show or to help us make the graph. Okay? And so what I want you to do is think about what would each of those intercepts look like. So take a moment. Again, when you're finding the x-intercept, you want to plug in 0 for y. When you're finding the y-intercept, plug in 0 for x. And then when you have those intercepts, you can continue on. All right, so hopefully as you found the x-intercept and you plugged in 0 for y, we would be left with 4x is equal to 180, which means when we divide by 4, x is equal to 45. So that point is 45, 0. For our y-intercept, when we plug in 0 for x, we've got 6y is equal to 180, divide by 6, and y is equal to 30. So 0, 30. So now when we go to graph that, we're going to put x, so like our small tables, down on the x-axis, and y, that's going to be the large tables on the y-axis. I'm going to count, I guess, by fives. I'm only labeling every 10, but notice how I'm skipping a line here. So this would have been 5, 10, 15, 20, and so on. Okay, so when I go to plot these points, I've got 45, 0 right here for the x-intercept. I've got 0, 30 right here for the y-intercept. And I've got the line between the two. Okay, so last thing, what would be some actual combinations of tables that would make sense for this event? Well, you could do, right, all 30 large tables. If I pick 0 small tables, I could see everybody with 30 large tables. Or I could only choose small tables and I could use 45 of those, right? Those would be two possible solutions. When we're looking for other combinations, we're looking for other points on the line. Now, every single point on the line is technically a solution to the equation, but when we think about having tables, we're not going to have a partial, like we can't rent half of a table. We could rent a whole table and then just not fill it completely, right? But what we're looking for is hopefully some actual numbers where we would need exactly that number of small tables and that number of large tables. So I'm thinking a point right here where I have 15 small tables and 20 large tables, that would seat exactly 180 people. And I see one more point right here where it looks like I would need exactly 30 small tables and exactly 10 large tables. So those would be 4 possible combinations that would perfectly sit all 180 people. All right, so last thing here, let's reflect on something that you either learned or were reminded of and any questions that you have. And we'll follow up in class tomorrow. Remember to write at least one thing for each prompt. All right, thanks for watching.